1-hour lecture on Bitcoin. We're going to solve some exponential equations, which we've actually already done once. We already solved exponential equations once. That was like base exponential equations. Now we're going to solve what happens when you don't have like base equations. So what happens when you get this? And the question just says solve that thing. Solve means figure out what x equals. My recommendation was make that like bases. You can't, right? I can't rewrite 12 as 4 to the power of something. I don't know what that is. I could rewrite 4 to be 2 to the power of something, but I still can't do 12 2 to the power of something. Right? So I can't do like bases. When you can't do like bases, you're going to have to use logs. This is a more basic question that I think we've actually seen before. So if you're solving for an exponent, you convert it to a log. The base of the log becomes the base, the base of the power becomes the base of the log. The other side of the equal sign goes into the argument. And then the exponent is isolated. You then have log base 4 of 12 equals x. You could throw that thing into your calculator. If you have the log base feature, sweet. If you don't, go log 12 divided by log 4, right? Use your change of base, and you get 1.79 equals x. For the record, that is a rounded answer. An exact value answer would be log 4 of 12. You could just leave it like that. That's like a basic exponential. We're like, yeah, that's good. Over here, same situation happens, right? It says solve. X is in the exponent. I can't do like bases, so I convert into a log. You go log power of the base of the power becomes base of the log. Whatever was on the other side goes into the argument. And the exponent is now isolated. This exponent is x plus 2. Not just x. So your last step would have to be subtracting that 2 to the other side. To give me log base 7 of 41 minus 2 equals x. That would be your exact value answer. If you calculated it, you would get negative 0.9. Negative 0.09. We good with those two? That's like pretty straight up, like that's kind of from like our start of our log stuff, right? No questions before it gets hard? Yeah, you're good to go. Good luck, have fun, hey? On your drive there, buy some Bitcoin or something. All right, let's try harder ones. Okay. There's a key to this question. This question doesn't just say solve. It says solve algebraically. That means you got to do algebra. It's got to be by hand. You have to show your steps. Okay? We will do solving with a calculator, with graphing. That would not work here. So if you know that trick, no bueno when it says algebraically. Right? You got to do the math now. Perfect. We got a problem with this first question. What's that problem? No like bases. X's in both powers. That's a problem for us. We haven't seen that before. We haven't seen, what do you do when there's an X on both sides? The reason that's an issue, don't write down what I'm about to write down, is if I change this to be a log, Like, that's good. The 4 would go there. That's fine. But now I have an x stuck inside the log, right? Which becomes a bit of an issue for us. You could like work your way out of it and manipulate it a little bit and calculate that way, but that just tends to cause more issues than not. So when we have, there we go, an x on both sides like that, what I would do is I would log base 10 both sides. So you can do something called logging both sides. I think that's the phrase that those of you who took this class last night, that's what you heard, right? Log both sides. That's what she says? Good, good. I try to keep the words at least the same. She would log both sides. Concept's the same. I want to use the same terminology too. Help you guys out. What that means is this is now log base 10 of 4 to the power of x plus 1. Like that. This side is log base 10 of 5x minus 2. The reason it's handy to log both sides is because now both exponents can use our log law where those go in front of the log. So I have x plus 1 log 4 equals x minus 2 log 5. So the new concept here is logging both sides. Then we use a log law, dropping the exponent down. At that point, I've dealt with my issue of the x being in the exponent. Like, that's now gone, which is good, right? That helps us. But I've created like a bigger problem by looks of it, right? I've got like multiple x's still. I've got logs going on. So it just looks more complex. What type of equation is this? So remember we talked about like quadratic equations and stuff like that. Like, what type of equation is this? If you were to guess. Oof. Definitely a polynomial. It's a linear equation. Remember that term? Why is it linear? Highest exponent is 1, right? So typically to solve linear equations, we need to expand and then get all of our x's on one side, all of our numbers on the other. So we're going to have to actually expand these brackets. So it becomes x log 4 plus 1 log 4 equals x log 5 minus 2 log 5. And now I can definitely see it's a linear equation, right? I have x to the power of 1s after I've expanded. To solve a linear equation, you move all of your x's to one side. To move my x's to one side, I would have to subtract that x log 5 from the right to the left. Those are not like terms, right? X log 4, x log 5, not like. So I would have to write it like this. X log 4 minus x log 5 plus 1 log 4. I'm not putting the 1 anymore. You don't need to put 1 times something, right? Just log 4 is fine. Equals negative 2 log 5.
Could you have also moved the x log 4?
Other direction? Definitely.
Okay.
Yeah, so I just chose to put my x's to the left. If you were ahead of me and you put your x's to the right, that's the same idea. As long as you're getting your x's on the same side, right? That's how we solve linears. Get the x's to the same side. Once the x's are on the same side of the equal sign, here's my equal sign. X's are all on the left. I now need to move my numbers to the other side. So I have to start moving the terms over. I have plus log 4. I need to subtract that to the other side. Giving me x log 4 minus x log 5 equals negative 2 log 5 minus log 4. Gonna make sure you have that written down. So then we're gonna do something that we really haven't done when it comes to solving linear equations. At least not that I can think of in any 20-1 class. Actually, before I do what I'm about to do, are we okay with the algebra of moving the x's to the left and moving the logs to the right? Does that feel all right? So. It's a little weird to move numbers that are logs, right? I get that. That's weird. All right, here's our problem. I'm going to move this log 4 over here, and I move this log 5 over here. Now, normally, you would move something by adding or subtracting it. If you moved it right now, then you're moving the x with it, which is not good. So then you get in this like weird situation where like to move this log 5, I would have to divide by log 5. If you divide it by log 5, then you're also dividing this by log 5, which is going to make a mess. And then if you divide by log 4, it makes this one a mess. So you're in like a weird spot here. What we're going to do to help ourselves out on that left side of the equal sign is we're going to try to get the x away from the logs rather than get the logs away from the x. The way I could get those x's on the left side away from those logs is by doing a greatest common factor. I could GCF an x out. So if I look at that left-hand side, they both could divide by x, meaning that the x goes out front, and I'm left with log 4 minus log 5. Equals that entire mess over there, negative 2 log 5 minus log 4. Now, I could get the x by itself. Because now, I could divide this entire binomial to the other side, leaving the x alone. Which is exactly what you wanted with a linear equation, was to get that x by itself. So we're going to divide our binomial log 4 minus log 5. And I have x equals that entire mess on the right side. So negative 2 log 5 minus log 4 divided by log 4 minus log 5. and I've successfully solved for x. That answer is an exact value. If it wanted a decimal answer, then you could put that into your calculator in chunks and kind of just solve it. Because they're all log base 10, it's actually not that terrible in your calculator. Right? You just go -2 log 5 minus log 4, and you just do the normal calculations. The question asked, did it say what it wanted? Nearest hundredth. Okay. So if you try to put this in your calculator, I'm a little paranoid when it comes to my calculator. So I would actually probably calculate the numerator first, and then calculate the denominator second, and then I would do the division. And that's just me being paranoid. You try it. See if you can put that in your calculator. I will also, so you can check your decimal to see if you get the right decimal. Okay, I think that's probably a smart move. You should be trying it right now to see if you can get the same thing I get. Oh, the numbers actually work out very nice so far. I got x equals 20.64.
Is it negative or positive?
Negative. Nope, positive.
Because I got a negative answer.
Beautiful. Okay, that is a hard question. Again, it's one of those things like you're going to need to practice it, right? Beauty.